Hello, and welcome to a tour of the C++ engine, which powers that MMO design tool called Figma. My name is Joey Liaw, and I've been on the editor platform team here for 4 years. And I'm very excited to share with you a little bit about how the Figma editor does its magic, as well as the inspirations that we've taken from game technologies. I think a lot of software engineers at some point in their career have thought about working on a game, or maybe even tinkered with working on a game, or if you're really lucky, actually shipped a game. And I got into computer programming because of gaming. It doesn't matter if it's a systems puzzler or an epic RPG. When I am playing a good game, I experience this feeling of wonder, like I'm being taken to another place. And I look at that screen and think to myself, I want to make that. How can I make that? And how do they make those animations? Particle systems, physics, audio, input devices, low latency networking, multi-texture, multi-platform, build these incredible worlds, have these incredible user interfaces, but also delightful user interactions. Amazing tutorials at the beginning of games, security and access controls, of course, building an incredible community, having a commitment to accessibility, having localization, and of course, mods. And games made me interested then in learning every area of computer science. Whenever I have the privilege of interviewing a candidate, almost invariably they will ask me the same question, and that is, what do you like about working on Figma? And I almost always have the same answer. I've pretty much had the same answer for the last 4 years, and it's that, even though Figma has many of the same system components as a traditional web app, it doesn't really ever feel like I'm working on one because we have so many of these interesting systems in addition to that. And it feels a lot like working on a massively multiplayer online game that happens to be about design, about whiteboarding, about creativity, about collaboration. And I'm always humbled to be invited to a user's file to help debug something. Because to me, it's like stepping through a portal into another world. And I'm flying in and zooming in on a completely new map that I've never seen before. And some of these are built by hundreds of people over thousands of hours with millions of elements. And I tell the candidates, there's never a dull moment for me at Figma because, we've got animations and particle systems. We've got layout constraint systems, audio and voice chat. We support all sorts of interesting input devices. We've got low latency networking. We have to support lots of images and textures. We target multi-platform. We have our own world building tools. We have really fun, intuitive user interfaces, but also delightful user interactions. And very rich tutorials when you first come on, and also a lot of security and access controls. Of course, our community is absolutely lovely, and we have a commitment to accessibility and localization. And of course, plugins and widgets are just mind-blowing what the community has created. I get to work on these things in an environment that has the highest level of employee diversity I've ever experienced in the tech industry. The workplace feels very safe in that ideas can come from anyone, and they're evaluated on their merits. When things do go wrong, we don't have a culture of blame. Instead, we try to find the root causes, and as a team, address those problems. Our engineering team has a higher representation of female and minority engineers because not only do we have an awesome recruiting team, but Figmates tell their friends that this is a great place to do engineering. When Figma first launched many years ago, there were a lot of naysayers who claimed that, oh, a design tool running in the sandbox of the browser would always merely be a toy and could not compete with native design apps running outside of the browser, and that Figma would not be a serious tool for doing design. But I think it's pretty clear to everyone today that Figma is absolutely an essential part of serious design business, and it meets or exceeds the capabilities of competitors that are running natively on people's machines. And I think it is precisely because Figma found a way to turn those limitations into a source of strength. When a hardware game console like PlayStation is released to the public, that hardware, those specs are set in stone. You can't upgrade the physical piece of hardware that's sitting in your home. So for that generation, year after year, game developers and game designers learn how to squeeze ever more performance out of the same silicon. And I am always completely blown away by the visuals that game developers are able to achieve when a game console's lifecycle matures. The web browser, which has had to support decades of web standards, is in a way a kind of slowly evolving virtual game console. And the limitations and graphical APIs have been unchanged for quite some time. And this allows Figma to continuously refine and optimize our code, as our users depend on Figma to support larger and larger design files. I think the end result is that Figma has a highly polished, highly engineered code base where trade-offs and costs are carefully weighed when features are introduced. So let's talk about how Figma actually runs like a highly optimized game in the browser. When changes are made to a Figma file, the visible portion of the file needs to be updated at 60 frames per second so that the user doesn't perceive any lag. While at the same time, the user might be interacting with complex user interface components such as the layer and property controls. And we handle these different goals by using two very different languages, C++ and TypeScript. Now, many popular websites and apps are written in the TypeScript language using a framework called React. And it's great for quickly building and iterating on user interfaces such as the layers panel and the properties panel. Figma's graphics renderer and scene graph, however, are written in C++. And what is the scene graph? The scene graph is the in-memory database which holds all the layer properties in a Figma file. And the renderer takes that data, converts it into WebGL commands, and then refreshes the screen as quickly as possible using the GPU. Although writing C++ can be more challenging than writing TypeScript sometimes, the language helps these data and performance-intensive parts of Figma achieve consistently high frame rates and performance, even when editing large user files, a feat that would be much more difficult for us to achieve consistently in TypeScript. Now, there are many commercial and open source game engines written in C++. So there is a vast amount of technical knowledge and resources from which we can draw inspiration. Compared to TypeScript, C++ gives you much tighter control over CPU usage and memory. And this is critical for making Figma work, because we're targeting the browser. And that's a platform that comes with a lot of constraints. Browsers are an incredible piece of ubiquitous technology and has undeniably been a major component of Figma's success. But programs running on a web browser are restricted in what they can do. When you open up hundreds of tabs in the browsers, you don't want these tabs to eat up resources on your device and cause it to crash. So browsers restrict the amount of CPU time and memory that a single tab can use before it gets forcibly shut down. Now, when I joined Figma in the spring of 2018, the entire company fit into a cozy office above a bar in Soma. And Figma was just gaining traction with enterprise customers, those early trailblazers who were ready to invest in Figma's vision of a deeply collaborative design system. At that time, the designers at one of our largest customers had created the most complex file that we had ever seen. And their designers were running into some problems. They were reporting crashes and slowness in the editor, and sometimes even had trouble opening their main design file. This all went down my first week, and it was a huge red alert. All hands on deck, working to solve this problem and unblock our users. We quickly realized that this design file had over 1 million layers, and it was causing Figma to run up against those strict memory requirements, limits set by the browser. And the first thing we needed was an emergency fix to stop this delicious multi-layer cake from exploding. We noticed that of those 1 million layers, many of them were actually marked invisible. So this was 2018, years before we introduced component states. So designers were manually creating something like states by authoring very heavyweight component that had many nested component instances, one for every possible state with just a few overrides changed. And you would change the visible state simply by toggling the one state that you wanted to be visible and everything else to be invisible. And this process was repeated at multiple levels like a design fractal, ending up with invisible layers everywhere. So we made an emergency change to the component system in the scene graph so that invisible instances inside components no longer take up any memory. This immediately gave us about 50% of the scene graph memory back on this one huge file, and that was amazing. We gained some breathing room for a little while, and the red alert was over, but we knew that this was just a one-time fix, and it was only a matter of time before design files would start to push the limit again. So we needed to dive deeper and find longer-term, more general solutions to our memory woes. And so began an optimization effort that was a very long battle of inches. We knew that layer properties took up the majority of memory, but there wasn't a second silver bullet that would drastically reduce it for us in a single go. We discovered instead that there are a lot of little things we could do that would shave off 1%, 2% there. If we kept chipping away at it, we could accumulate some pretty major savings over time. We found, for instance, that a lot of layer properties were actually duplicated in many different places. For example, a certain gradient might have been copied to many elements, or many layers might have the same generic name, such as rectangle. So we introduced a deduplication system that makes it very easy for engineers to opt in C++ classes to be deduplicated. And we put gradients and strings in this deduplication system first. Over time, we migrated dozens of layer properties to be deduplicated, and this ended up, in aggregate, saving a good chunk of memory. We also noticed that we were wasting some memory in fields that were not used very often, but still took up memory for every layer. So we borrowed a technique used from game engines and databases. Instead of storing rows of complex layer properties, we could pull out individual columns of these rarely used fields into their own tables and compress them separately, taking advantage of the distribution of the values for that property. Again, this resulted in a few percentage savings for every field that we could migrate to columnar storage. Another big optimization concept from games is level of detail, or LOD for short. And this makes those real-time rendering of epic scenes with vast landscapes and thousands of on-screen elements possible by drawing lower-level detail versions of the far-away things like grass and trees and mountains, and saving memory then for higher detail versions of characters close to the camera. And these past few weeks, we've been rolling out a new LOD system for managing images that does something similar for the camera in Figma, based on your current page and view zoom level. And our user analytics shows very promising results in memory savings from this new system. Now, beyond memory optimization, as I mentioned before, C++ gives us more speed and control than TypeScript, but it comes at a cost. And that is a certain class of bugs called memory safety. In order to maintain the integrity of user data, which is absolutely the highest priority of the engineering team at Figma, we introduced a new safe generational pointer that is a technique that's been used in game engines for quite some time. And we replaced all the raw pointers to the scene graph with these tagged pointers, and they carry around extra bits of information that help us prevent undefined behavior from happening. So if any code tries to read properties from a null pointer or from a layer that's already been deleted, we prevent any change to actual user data and generate an error report. Combined with a custom allocator, this augmented pointer system ended up speeding up layer allocation speed by an order of magnitude. So we ended up making files load faster while also making data safer. And when it comes to bugs, in an internet-connected collective creativity experience, we have powerful developer and analytics tools at our command to debug and diagnose problems. Every error and crash that happens generates a report which has the entire stack trace of TypeScript and C++ code interwoven together. Besides these error reports, we also track events that are related to performance, memory usage, and feature utilization. We then set up detailed dashboards that can help us answer questions like, what percentage of frames are hitting 60 FPS across all of our users? How long are files taking to load across our population? Was there any unusual error spikes just after that deploy that happened an hour ago? And as part of our team's daily on-call runbook, we check these dashboards every day for any anomalies and quickly get eyes on anything that looks problematic. In order to minimize the impact of Figma updates to our users, we keep tabs on Figma's program size and keep it as small as possible. This lets us push out a new version of Figma every weekday. And unlike most games or native applications, where patches are released on a monthly or quarterly basis, Figma engineers can get feedback on a new feature or bug very quickly after it is written. And betting on browsers has definitely paid off here, because these daily updates can go out to all of our users on all of our platforms on every form factor, desktop, tablet, and phone at the same time, because of the incredibly heavy lift of supporting multiple operating systems, CPUs, GPUs. This has thankfully been largely abstracted away for us by the incredibly talented engineering teams working on Firefox, Chromium, Safari, and Edge. I want to close by making a special call out to Figma's engineering culture. We work closely with our product and design teams, and we're also so lucky to have an incredible support team that helps us triage user bug reports. And down at the code level, we are continuously striving to find ways to make it easier for engineers with different backgrounds to feel productive in both TypeScript and C++ and make their changes in confidence. For example, we've wrapped containers from the standard template library with our own interfaces that make common mistakes difficult to do and provides methods similar to those on native JavaScript containers. And a year ago, we finished our migration to C++ 17, and we hope to get to C++ 20 soon in the future. This will give our engineers much welcomed upgrades in convenience, performance, and safety. And we're currently undertaking an exciting effort to make C++ data even easier to access from our TypeScript code, which will increase the pace of development of future features. At the organizational level, I'm so very impressed with the significant investments and collective contributions people have made to our documentation and style guides, to our code review standards, the amount of time and energy invested in training and mentorship, our incredible automated testing pipeline, and all the on-call processes that we have put together. With blameless postmortems and a wonderful work-life balance, this is by far the most diverse and dynamic engineering org of which I've had the honor of being a contributor. And I hope that you, our users, can feel the collaborative and inclusive spirit of Figma's culture every time you use our products. If any of the topics I've talked about sound like interesting problems you'd like to work on, in an environment that helps people thrive and grow, please check us out. We're hiring. And thank you for watching today. I hope you've enjoyed this tour of Figma C++ engine, and I'm happy to continue the discussion and answer any questions on Twitter. Thank you.